Some more features about trig functions. So we need to remember that trig functions are periodic, so they just continue on and on and on and on. So if you think about your circle, it can just keep opening up wider and wider with more and more and more and more and more and more rotations over and over and over and over again. We're going to end up in the same places on our unit circle, no matter where, as we keep going around and around and around and around. So sine of 0 is equal to the sine of 2 equal to the sine of 4 is equal to the height at the sine of 6 pi and the sine of 8 pi, which in general, if we call this an angle t, the sine of t is equal to t plus 2 pi. So all of its coterminal angles. We've been talking a lot about this. The cosine of pi and 3 pi, 5 pi is equal to the cosine of 7 pi, 9 pi. So what am I doing there to each angle? I'm adding 2 pi times n. 2 pi times n. I need to add that n in there, up in the sine. Okay. So we're going to evaluate sine of 13 pi over 6 using our ideas of periodic functions. So I know that the sine of 13 pi over 6 is equal to the sine of, how many full rotations can I take out of 13 pi over 6? So 2 pi here. So 2 pi written with 6 would be 12 pi over 6. So how many 12 pi's over 6 can I take out? Just 1. So 13 pi over 6 has a coterminal angle at pi over 6. So I'm going to go back to my unit circle. Actually, I'm just going to draw it because that's even better. And be like, okay, pi over 6 right there. That means that the side length, the y side length is 1/2 at pi over 6. So the sine of 13 pi over 6 is equal to the sine of pi over 6, which is equal to the ratio of 1/2. Okay. All right, again, cosine of negative 7 pi over 2 is equal to the cosine of, see, we're dividing by 2 this time, so 4 pi over 2. How many times can I take out 4 pi over 2's? Well, see, let's just subtract them. It looks like we can take out that times 1, leaving us with negative 3 pi over 2 left over. So the cosine of negative 7 pi over 2 is equal to its coterminal angle, the cosine of the coterminal angle, 3 pi over 2. So we're going negative this direction, starting at 0, ending at 90, or pi over 2. That would be negative 3 pi over 2. Okay, so on the unit circle at negative 3 pi over 2, the coordinate is 0, 1, and the cosine has to do with the x coordinate, so the cosine of negative 3 pi over 2 is equal to 0. So the cosine of negative 7 pi over 2 or negative 3 pi over 2 is equal to 0. We move nothing left or right. All right, trig functions are also even or odd. So just remember, even functions are when f of negative x is equal to f of x, and odd functions are when f of negative x is equal to the negative output, so negative f of x. The cosine of negative t is equal to, I'll just give you this one, cosine of negative t is equal to the that was crazy, cosine of t, and because cosine and secant are reciprocals, then the secant of negative t is equal to the secant of positive t, which makes these even functions. Okay, sine and tangent and its reciprocals are odd functions. So the sine of negative t is equal to negative sine of positive t. Its reciprocal is equal to the cosecant of positive t. Tangent negative t is equal to negative tangent t. And cotangent of negative t is equal to the negative cotangent of positive t. So using our rules, if cosine of negative t is equal to 1/4, then cosine of t, let's see, it looks like when my input is negative, then I know that the cosine, well, things are going crazy today. Cosine of negative t is equal to the cosine of t. The cosine of negative t is 1/4, so cosine of t must be equal to 1/4 as well. So if the secant of negative t is equal to the secant of positive t, then I just remember that secant and cosine are reciprocals. So the secant of t is equal to 4. And so the secant of negative t would equal 4. So it's just the reciprocal of cosine as well at that point. All right, lastly, here's a little radian measure. We're going to look at the sine of 3 radians. So I'm going to look at on the circle, opening up to 3 right here. So I have an angle that moves from our x-axis to 3. That's a very bad line. Okay. So how far is sine x or y on the unit circle? It looks like our radius is equal to 1. So how far over and up are we moving? We're going to guesstimate. So I moved almost all the way over to 1, so like 0.97 maybe. And actually, is the x the sine or is cosine the y? So remember, sine is equal to the y and cosine is equal to the x. So I actually need to take this business over here and move it as my cosine value. The sine, how far did I move up to get to 3, would be like 0.2. 0.2. So this point is 0.97, negative, comma 0.2, about. Okay, 5.57. So this time I'm going to move all the way from here all the way to 5.57. So we have starting at 0, moving to 5.75. I think I said that transposed. Sorry. So my x is equal to a little more than 0.8, so 0.88 maybe. Positive, and my y is equal to, let's see, you mean negative 0.5. So the sine is my x, so it's going to be, sorry, I said that backwards. So sine is my y, so negative 0.5, and cosine is the x value of the point, so 0.88 positive. So the x in each ordered pair relates to the sine of theta, of your angle. Actually, we can write it out. And the y, I don't know why I keep saying these backwards. I apologize. Okay, the x value relates to the cosine, you should know this from the Ferris wheel, of your angle. And the y value relates to the sine of your angle. The sine ratio, cosine ratio, sine ratio. That was really long, so I'm going to split this up over 2 days.